Welcome back to iCode. This is Biweekly Leetcode Biweekly contest 83, and I'm going to solve number of zero-filled subarrays. It's a medium level question. So the question says we are given a number of nums array. It has zeros in it, and then it says count the contiguous non-empty subsequence which has zeros. So when I look at this example, there are four occurrences of zero. So since we have four zeros here, 1 2 3 4, there are two occurrences of the subarray that contains two zeros. One is here and another one is here. Sum of those is 6. Looking to the next one, here we have 1 2 3 5 zeros, so we have those 5 occurrences. For 2 we have one here and one here. So since we are this one, so those are 3 here, 3 occurrences, and then only one occurrence of this. So when we look at this, initially we counting same 0 in multiple subarrays, because this one can form the subarray of itself, but then this one contributes to subarray of 2 and again contributes to the subarray of the 3. So this sounds like initially as a factorial problem, but let's take a look at this example. How can we do this? So when I have subarray with 0, then my count is 1, right? And that gives me the combination of, like, I get a one subarray. When I have subarray like this, the count of the subarray, length of the subarray is 2, right? And then how many combinations I get? I'm gonna get 1 of 2 and then 2 individuals, so I get 3, right? And then when I have 3, count is going to be 3, right? Count of zeros is 3. And how many combinations I get? Combinations I'm getting is 1 of 3, right? 2 of 2 plus, and 1 of 3. Sorry, 1 of 3 is 1 of 2, and then 3 of 1 single 0, right? So this is actually addition. It's not factorial, it's addition. So if we do addition going ahead, then so this is, what's this total? 3 2 5 6. So this is 6 and this is 3, we get 9, right? We get 9, and there we go, answer is 9. So what we need to do is, for each subarray we have to have one local contiguous, one subarray of the 0 we have to have one local count, and then one maximum count, like one count outside to give the final result, which will count for all the subarrays. Okay, let me show you the code, and it will be more clear. So now I'm gonna go ahead, declare total equal to 0. This is the final answer. And then I'm gonna go ahead and use while loops. You can go ahead and use for loops as well. So I is equal to 0, and then while I is less than length of nums, and now is the time where this is the count for individual subarrays. So this count is going to be 3 for this, then it will reset to the 0 when we go to 2, and then when we start again, this subarray it's going to be 2, right? So that's that count. And then again, while I is less than length of nums, just to check that we don't go out of bounds, and then nums of I equals to 0, right? If that happens, if I encounter 0 in the array, count is going to be 1, count plus equal 1, and I'm going to do is I'm going to add count to my total itself, because remember we did 1 then 3, sorry, 1 2 3. It's a for this. So the count itself, you can add this count itself. So this is one combination, this is one combination, you add that. This gives me two combinations, sorry, three combinations, you add that directly, right? So you can just add total, count to the total, right? And then I increments here, since it's a while loop. And then if it is not 0, if nums of I is not 0, you need to go ahead and simply increment, don't do anything, and in the end you should just return total. Let's see if this works. Okay, this works. I'm gonna try a couple of these test cases. And then this one, which should return 0. Okay, there you go, 690 690. Okay, so time complexity wise, it's big of and very iterating over the array, right? So it's a big of one time complexity, sorry, big of n, and the space is big of 1, since we just have two variables, right? So space will be big of 1, right? Okay, so this is it. This is, you can use for here for loops. And okay, let me know if you like this video. If this is helpful, please hit the like button and subscribe, it helps the channel.